Welcome to Study Loop.
Hi friends, here it is given a refrigerator using a refrigerant R134A as working fluid and operates on ideal vapor compression refrigeration cycle except for compression process. We have to find mass flow rate of the refrigerant, condenser pressure, and coefficient of performance. Let us hear the analysis. First, we will discuss the assumption for solution. First one, steady operating conditions exist. Second, no loss of kinetic energy and potential energy. For analysis, we use refrigerant table for R134A, A11 and A13, P4 120 kilopascal and X4 is given 0.34. Heat capacity is 95.41 kilojoule per kg. H3 to be equal to H4. H3 is 95.41 kilojoule per kg. X3 is 0, saturated liquid, and pressure is 799 kilopascal or approximately 800 kilopascal. You may write P2 is equal to P3. P2 is 800 kilopascal. T2 is 70 degrees Celsius. Heat capacity in this state is 306.92 kilojoule per kg. P1 is equal to P4 120 kilopascal and X1 is equal to 1 saturated vapor. And heat capacity in this state is 236.99 kilojoule per kg. First part, the mass flow rate is defined as power input upon H2 minus H1. H2 minus H1. Power input is given 0.45 kilowatt. H2 is 306.92 minus 236.99 kilojoule per kg. So mass flow rate you will get 0.006435 kg per second. This is the answer of part A. In part B, we have to find condenser pressure. Condenser pressure will be equal to P2 and it is to be 800 kilopascal. Now C part, refrigeration load and coefficient of performance, that is rate of heat flow at sink or at low temperature, mass flow rate into H1 minus H4 0.06435 into 236.99 minus 95.41. So it is to be 0.911 kilowatt. Coefficient of performance is defined as rate of transfer of heat to the low temperature into power input. So 0.9111 upon 0.45, that will be 2.03. That's all for it. Thanks for watching it.